So yeah, hi everybody. My name is Natasha. I'm a volunteer for Women Who Code. I'm also a software engineer, currently at the Digital Intelligence Service of the Singapore Armed Forces. I don't ask me more questions about that. This is mostly a Darsh's show, but basically, Women Who Code is a community of innovators and engineers that have come together and they're trying to champion greater diversity in the field of tech. So today we're very lucky to have with us Adharsh, who is a robotics engineer at Panasonic. He'll introduce himself more later, but he's going to be talking about opportunities in robotics. So first and foremost, let's talk about the mission of Women Who Code. So we empower diverse women and actually men to excel in technology careers in general. So we're here trying to spread awareness. We're here trying to let people know, look, all these diverse fields are available for you in the world of tech. Like for today, we're trying to expose you guys to the field of robotics, which is a little bit more unknown as compared to the hype over artificial intelligence and software. So that's kind of what we are aiming to do, to empower like a diverse community of people so that they have access to information on these technology careers. So yes, so our vision is basically a tech industry where diverse women and historically excluded people thrive at every level in their career. So we're not just looking at entry level, like trying to help match people to jobs and trying to gain awareness. We're also looking at different people across the technology levels, like engineering managers, staff engineers, principals, blah, 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 stuff like that. So we also have a lot of other events across the community, not just in Singapore, but our other chapters. Like today, I actually just met with another volunteer. Her name is Umin. She's a staff engineer, and she was just talking about how she wants to do something for engineering managers. So you can look forward to a variety of these topics that Women in Code. All right. Okay, our values, we have the four main values. One is to really focus on our mission. We remember that we're here to basically empower the diverse community of tech careerists to expose people to the variety of fields in our career. And we're always going to remember that that's the core of our mission. We're also looking to design for inclusion, make a space and embody a culture of belonging for everybody, both not just for women, but also for men, and also for historically excluded people. We're looking to be advocates for change. So every little step goes a long way. We're going to live and breathe leadership. We're going to champion each other. And as a community, we know we're going to be more powerful than individuals, and we're all advocates in this. And lastly, we're going to journey forward, recharge. We're going to celebrate wins, to break barriers. So it's not just about like the serious, like tech talks. We also have like community events to bring everybody together. So we know that, you know, we're all like a fun community where everybody has a space to belong to. So Women Who Code is not just a Singapore organization. We have 320,000 members from all across the world. And when I say across the world, it really is across the world. This is like your entire map on this page. So Singapore is just like one community. We have a lot of like different people from all around. Like I was just in Tokyo 2 weeks ago, and we have like a chapter in Japan as well that's also doing different things there. And I think they do have like a talk in robotics or like a little study session too. So they're also interested in that. So 147 countries, and Women Who Code is in all of them. Lastly, our code of conduct is that Women Who Code is an inclusive community. We are very much dedicated to providing an empowering experience for everyone who participates in and supports our community. So we're looking at supporting everybody regardless of gender, gender identity and expression, sexual orientation, ability, physical appearance, body size, race, ethnicity, age, religion, socioeconomic status, caste, creed, blah, blah, political affiliation, or preferred programming languages. I am bound to actually like say all of this, so I just kind of breezed through that really fast. So yeah, if you want to see like the whole code of conduct, you can go on to womenwhocode.com. And lastly, if you want to stay connected and look up for more events like today, where we have Adharsh on board to talk about robotics, join our website, just kind of type Women Who Code, and you can find us on all the different socials at the handle www.code_Singapore. And we'll kind of bring this back to the end of the session so you know. So thank you to connect with us over our social media handles. And now we're going to jump and deep dive into our guest speaker for today. Our guest speaker for today is Adharsh. Yeah, Adharsh, maybe like say hello. Hi, everybody. So there he is waving. So Adharsh is an incredible software engineer. He is a robotics engineer 3 at Panasonic. I think I will love us as Panasonic. He's been working in the field of robotics for more than 2 years now. After he graduated from a master's degree in computer control and automation from NTU Singapore. And I know he did a little bit of like electrical engineering as well before that, but you're going to dive into that. His areas of expertise across his career includes robot navigation, perception, and fleet management. And during his free time, Adharsh enjoys watching movies, cooking, and running. So without further ado, I'm going to pass over to Adharsh right now so he can tell you all about his life as a robotics engineer, how he came into it, and as well as all the different opportunities you can look forward to here. So I am going to stop share right now. And Adharsh, feel free to take over.
Thank you, Natasha, for the wonderful introduction. Let me quickly start sharing my screen.
You're good. Yeah. We can all see it.
Okay. Hello, everyone. Thank you for taking time out on the weekend. I know you all are spending your valuable Saturday afternoons here with me. I will try to keep this talk as crisp as I can. In today's session, I'm going to be giving a brief introduction of robotics, talk about different types of robots, some of the major subdomains, share with you the vast applications of the field, give you a glimpse of what the future holds for robotics, some challenges facing the field of robotics, how you can decide if robotics is for you, and towards the end, I'll also be sharing some practical tips to help you prepare for your first robotics job. Hopefully, by the end of the talk, you will be even more excited to get into the field of robotics. So let's get started. I would like to start off by talking a bit about my personal journey into robotics to show you that there isn't one right way to break into the field. Looking back, I've tried to summarize some key experiences I felt played a pivotal role in helping me land a job in robotics. I did my bachelor's in India, majoring in electronics and communication engineering. These 4 years, along with giving me a good foundational understanding of electronics, embedded technologies, and communication systems, also gave me a lot of freedom to explore opportunities outside the 4 walls of my classroom. In my second year, I was selected to be a part of a student team that participated in the CANSAT competition, which is an annual international collegiate organized by NASA and the American Astronautical Society. The mission was to simulate the landing sequence of a planetary probe. Being the avionics lead of my team, I was responsible for several areas, including sensor subsystem design and integration, flight software development, communication and data handling, as well as power management. After more than 10 months of grueling work and countless sleepless nights, my team qualified for the final stages of the competition, and we were invited to Texas among the top 25% of teams to take part in the finals. My team ended up securing a place in the top 20 among 100 plus teams that participated. Being involved with the end-to-end life cycle of a complex engineering project, from conceptual design through integration and testing, the actual operation of the system, and concluding with a post-mission summary and debrief, fortified my passion of bringing ideas to life and propelled my interest in further pursuing education in robotics. In the midst of COVID, I decided to come to NTU Singapore to pursue my master's in computer control and automation. This was an extremely fun time for me as I could take up subjects that I loved and really interested me, including machine vision, robotics and intelligent sensors, neural networks, and so on. It was also during this time that I started learning ROS, which is Robot Operating System, and working on several personal projects to put to practice all the knowledge I was gaining in class. As I was concluding my master's, I started applying to jobs and got a few breakthroughs. Most of the roles I landed were in academic research, but as I was interested to work in the industry, I chose to work with Panasonic as a robotics software engineer. Over the past 2+ years, I've had the opportunity to design, develop multiple mobile robotic systems, including perception, navigation, path planning, control, and fleet management, mainly focusing in the healthcare industry. I was also privileged to have my paper selected among the top 1/3 of submissions and was invited to deliver a talk in the robot fleet management track at ROSCON, which is an international conference where ROS developers from around the world meet up to share the latest developments in the field of robotics. Now, when we think of robotics, pop culture icons like Isaac Asimov's iRobot, the Gundam statues, and even the Transformers might spring to mind. These representations capture our imagination, pushing the boundaries of what machines can be. They embody our hopes, fears, and aspirations for the harmonious fusion of human and machine. But robotics is so much more than fiction. The world of robotics is fascinating, diverse, and filled with opportunities that are both real and within our grasp. It's the intersection of cutting-edge technology and practical solutions. The world of robotics is dynamic, offering tangible solutions to real-world problems. Every advancement is a step towards a more efficient and interconnected future. So buckle up as we embark on a journey to understand what robotics truly is and how you can shape the future with it. The vastness of the field of robotics is reflected in the diverse types of robots we have developed. Industrial robots streamline our manufacturing processes. Swarm robots show the power of collective intelligence. Androids and humanoids mimic human-like features and actions, bringing machines closer to our world. Aerial drones provide a bird's-eye view, revolutionizing industries from entertainment to agriculture. Underwater robots explore the deepest trenches of our oceans, while ground robots tread where humans might not be able to. Each type serves a unique purpose, driven by the limitless boundaries of human imagination. Robotics is a beautiful confluence of various disciplines. It stands at the intersection of electronics engineering, computer science, and mechanical engineering. From sensors and actuators in electronics to AI and software in computer science, and from kinematics to modeling in mechanical engineering, robotics weaves them all together. The following flowchart will give you a clear picture of some of the major subdomains that in one way or the other contribute to the field of robotics. This showcases the collaborative nature of modern scientific endeavors, proving that the most complex challenges are best met by interdisciplinary cooperation. Robotics is not just shaping, but truly transforming the world we live in. In healthcare, robots have moved beyond mere instruments to compassionate assistants, amplifying the capabilities of medical professionals and enriching patient care. Fun fact, in the first picture, you can see Panasonic's flagship product, the Hospi, which is an autonomous delivery robot used in hospitals to deliver medicines and other samples. This is also one of the projects I'm working on. Moving on, the industrial landscape is witnessing a paradigm shift, with robotics ensuring efficiency, consistency, and unparalleled precision, revolutionizing manufacturing processes. Space, which was once the final frontier, is now within our grasp. Robots designed for space exploration are extending our reach, bringing the mysteries of the cosmos closer to us. The e-commerce and logistics sectors are experiencing accelerated deliveries and enhanced customer experiences thanks to the drones that promise speed and efficiency. In our homes, robots are simplifying daily chores, making them less of a task and more of a seamless experience, blending effortlessly into our daily lives. Be it in the air, on the ground, or in the middle of the ocean, robotics is becoming an integral part of safekeeping forces around the world. From factories to our living rooms, from Earth to Mars, robots are not mere machines. They are the embodiment of human ingenuity, aspiration, and the promise of a brighter, more efficient future. As we gaze into the vast expanse of the future, it's clear that the horizon of robotics is limited only by the bounds of our imagination. Imagine a world where robots possess not just mechanical prowess, but also sophisticated cognitive faculties. This is the dawn of integrative AI. These robots won't just perform tasks, they'll think, perceive, decide, and adapt as seamlessly as you or I might in a new situation. It's not merely about teaching robots to work, but enabling them to understand. Bio-inspired designs are on the rise. Soon, we might see robots that flutter like birds, capturing the very essence of flight, or robotic hands designed with the intricate dexterity of our own, picking up objects with unparalleled precision and ease. We're not just creating, we're emulating the very best of nature. But the future of robotics is not a tale of human versus machine. No, it's a story of partnership. Collaborative robots or cobots will stand beside us, not as replacements, but as partners. They'll augment our skills, making our jobs easier, safer, and more efficient. We will wear our technology, quite literally. Exoskeletons will augment our natural abilities. It will help in rehabilitation, assist differently abled individuals, or boost the strength and endurance of workers in physically demanding jobs. The age of impersonal, task-specific robots is giving way to something more intimate. Personal robots will soon step into roles we hadn't envisioned. Beyond mere tools, they'll be our caregivers when we're frail, our companions in solitude, and even friends in moments of joy and sorrow. In essence, the future of robotics is a tapestry of dreams, innovations, and partnerships. It's a world where machines echo life, not just in function, but in spirit. Imagine for a moment you're teaching a toddler to pick up a fragile glass vase. The delicacy, the caution, the nuanced touch required. Now, translate that to a world of metal, wires, and code. Let's discuss some key challenges facing the field of robotics, starting with the complexity of real-world interaction. Firstly, let's talk about physical interaction. While many of us can easily pick up an egg or stroll across an uneven terrain, for robots, these tasks remain significant challenges. It's fascinating to think that what seems instinctual to us requires years of research in dexterity, balance, and force control for robots. Additionally, the unpredictability of dynamic environments like city streets or cluttered homes further complicates robot understanding. Predicting and navigating such terrains demands a level of adaptability robots are still striving to achieve. While robots grapple with the real-world intricacies, they also face a very fundamental challenge: the very energy that powers them. Energy remains a limiting factor, especially with battery limitations. As we know, our devices always seem to run out of juice at the most inconvenient times. Despite advancements, energy density and charging duration still need attention in the world of robotics. Efficiency isn't just a buzzword. Robots need to optimize both algorithms and mechanics to ensure that they make the most of their energy stores. As we juggle energy concerns, we can't ignore the cognitive demands we place on these machines. Unlike humans, robots don't naturally learn from experience. The challenge of embedding learning and adaptation in robots remain at the forefront of our mission. Another challenge is complex reasoning. Translating high-level cognitive tasks like planning and abstract thinking to robot-level language is no small feat. And of course, the age-old dilemma of autonomy versus control. How much freedom do we give our machines, and where do we draw the line? But understanding and decision-making aren't the only hurdles. Ensuring our safety and addressing ethical considerations is equally crucial. As robots become our colleagues, neighbors, and maybe even friends, human-robot collaboration must be intuitive and, above all, safe. With this rise in robotics, there's an urgent call for robust regulations and standards. Clear guidelines are essential to ensure the safety and efficacy of robotic applications. Beyond mechanics and programming, the ethical implications of robotics warrant deep contemplation. Issues like job displacement, privacy, and psychological impacts are discussions we must engage in as a society. However, as we address these ethical concerns, the practical barriers of cost and accessibility looms large. Bridging the gap between research and commercialization remains challenging. Many groundbreaking robotic technologies are confined to labs due to very high commercialization costs. Finally, as robots become an integral part of our lives and professions, there's an undeniable need for education and training. Preparing our workforce for a robotic future isn't just essential, it's inevitable. In conclusion, the robotic field holds immense promise, but like any other pioneering journey, it's paved with challenges and opportunities. With collaboration, innovation, and a touch of human spirit, I believe we can steer the world of robotics to a future that benefits us all. Are you someone with a burning passion for problem solving? Robotics isn't a silo, it's an orchestra of disciplines. Does the prospect of working in an interdisciplinary team excite you? Are you always driven by curiosity, eager to learn and adapt? Do you find joy in hands-on experimentation, building and iterating? And most importantly, do you dream of shaping the future of a world where humans and robots harmoniously coexist? If your heart resounds with a yes, then perhaps robotics is your calling. Finally, I would like to give you all an actionable roadmap to help you prepare for your first robotics job. Step 1 is to ask yourself a few questions. Which aspect of robotics do you want to work in? It can be hardware, it can be software, or even both. What type of robots excite you the most? And which field do you want to dive into? Now, once you've defined your niche, the second step is to start working on building some essential skills. This includes brushing up some fundamental concepts in maths and physics, picking up a programming language, getting familiar with a simulation or modeling platform, learning a version control software, as well as the containerization technology. Following this, you also need to study the basics of some field-specific algorithms. Once you've gained these essential skills, it's time for you to start working on personal projects to showcase these skills. I would highly recommend creating a portfolio. This can be in the form of a website, a blog, or even maintaining your GitHub profile. Last but not the least, you need to reach out to people in the industry and gain insights from them. This can be through networking on LinkedIn, attending more events like this, and even taking part in competitions, workshops, and conferences. I have curated some essential skills right from fundamental concepts in math, such as linear algebra and probability, in physics, such as kinematics and control theory, to software concepts and tools such as object-oriented programming, simulation platforms like Gazebo, modeling softwares like SolidWorks, as well as some version control and containerization tool. There are other field-specific algorithms that one should be aware of, ranging from path planning and motion control to a variety of AI algorithms. If you all are interested, I will be more than happy to cover these concepts in depth in my future talks. That brings me to the end of my presentation. I hope this brief session today was able to give you a sneak peek into the vast world of robotics. This will be the first of many talks we're planning to have on this platform. I will be more than happy to connect with you all on LinkedIn, as I'm always eager to chat about various topics in the field. Thank you so much for listening.
All right, perfect. Thanks so much, Adharsh. That was a really well put together information packet. I wouldn't even call it slides because you literally had like a tutorial on like step 1, step 2, step 3, step 4, step 5. Like, how do you get a job in robotics? Like, I love that slide. Honestly, like, I'll plug your socials in later in the chat, but I love that slide. And later on, I'm intending to like share it with everybody because it's so clear. I think you really like put together like a really good overview of robotics and kind of like explore the different domains in it. I love the part where, you know, you broke down what are like the different traits that, you know, would allow you to perhaps pursue a career in robotics, and the part about like you envision a future where robots and humans can live together. For some reason, I had this romantic like kind of vision in my head. Like, I don't know if you watched Ghibli, but there's this one animation called Castle in the Sky, and that's like literally what I had in my head when you said that. But yes, maybe I should be a robotics engineer now. But no, seriously, like that was a really good presentation. And I'm sure everybody had a good insight into robotics if you came in and you had no idea what the field of robotics engineering meant. I'm sure this presentation would have helped you. But beyond that, I'm sure you guys have a lot of questions that you would like to ask Adharsh about, like, you know, specific details that you saw in the presentation you want more information on, or perhaps like a little bit more about his journey, perhaps, you know, something like, okay, I see that you were doing electrical engineering. What made you want to pursue such a specific niche in your master's and then move on to like robotics engineering? Maybe that's a question you want to ask. Maybe you want to ask him more about like, so how was your job search? How did it kind of look like? Why did you land on Panasonic? So as I mentioned at the start, you guys can definitely like unmute yourself, or you can use the raise hand function, and then you can just go away. You want to go on and ask away, or you can put your questions in the chat. Like right now, I see Celine saying thank you, Adharsh. I see Ella. Yes, thank you. So interesting. Yeah, I'm sure Adharsh like appreciates all these comments. Like maybe Ella and Celine, did you have more questions like relating to the presentation? Yeah, feel free to type it in the chat. Like Celine, did you have any questions that you wanted to ask Adharsh? Feel free to unmute yourself. Let me see, like, oh, there you go. Yeah. Hi, Celine, can you hear us? Oh, maybe not. That's okay. Oh, there we go. So Chris just asked a question. Working in Panasonic company, a Japanese company. Oh, this is an interesting one. How is it compared to working in Singapore or other companies? Oh, this is a good question because Japanese working culture can be seen as quite intense, because I just came back from Japan and my friends were just like, oh yeah, I'm struggling. What do you think? Like, you're working based off Singapore, right? Even though it's a Japanese company. What do you think of the working culture?
Yeah, so I think that's a very interesting question that Chris asks us here. even though Panasonic is a Japanese company, the entity that I am employed in is in Panasonic Asia Pacific, which is not as much of a Japanese culture, I would say, compared to departments in Japan. But that being said, I think there's a lot of pros and some cons working in a Japanese company, but mostly pros, I would say. There's a lot of structure in place. There's a very structured way of approaching problems. I think one thing that's different. I wouldn't say good or bad. I think that's up to the up to people to perceive. But one thing that's different between say Panasonic and maybe a startup in Singapore, I would say is the the approach to solving problems. So Panasonic or any established company, I can say for that matter, will try to solve problems and keep that as a first reason to get into any industry. But if you take any other startups, then I think the focus is more on working or developing cutting edge technologies. And a lot of these companies get stuck in the final stage of, okay, we have such a good product that is very advanced compared to other products in the industry, but when they have to take it to the market, then there is a very big misfit in terms of the product and the market placement. So that's just an interesting thing that I've noticed. Yeah.
No, yeah, you're absolutely right. It's really about like how bigger established companies like Panasonic, they have like such a fixed user group that they've kind of expanded all over. They've been here forever. So they're focused on like solving problems that actually exist and then trying to find solutions to that. So that's kind of their approach. But with startups, they start with the solution first most times because they're trying to like get all the high cutting edge technology so that they can pitch to all your VCs out there. But at the same time, it's also finding that problem solution match, right, with like the different user markets. Yeah, so that's definitely true. And I'm sure that doesn't just apply to a Japanese company, but I'm sure it's a little bit more intensive with maybe a Japanese company because you're so like, I'm making assumptions here, but like they're perhaps more like focused on like serving the user and way more diligent in trying to serve their needs at that point. Okay. Oh, perfect. Thank you so much for that really holistic reply. We have a new question from Ella. Thank you, Ella. What other companies deal with robotics here in Singapore other than Panasonic and Siemens? I've seen the ST subsidiaries too. So maybe you can kind of talk about like in your job hunting, like what were the companies you kind of look at? And in your current role, are there other maybe firms that you kind of work with that you could talk about? What would you recommend for people to kind of look at if they want a career in robotics?
For sure, for sure. So I think that's a great question because being aware of the availability of companies is the first step before you can start looking out for jobs. But I think there's one question that you have to ask yourself, and that is which aspect of robotics do you want to work in? I think that's the first question you need to ask yourself, because most of these companies that are there focus on a specific field of robotics. For example, Panasonic, we focus mainly on mobile robots, and there are a lot of companies that focus mainly on mobile robots. So maybe if that isn't your interest, then there's a lot of companies that you will not be able to apply to. On the other hand, there's a lot of companies that focus simply on industrial robots or actuated robots, and that's a whole other field. So I think the list is quite extensive. Just maybe giving a few names here. I think you must have heard of like Dyson. Dyson is a vacuum cleaning company predominantly, but they're doing amazing work on the engineering front. So there's a lot of opportunities to join them. Yeah, ST Engineering, like she said, I think is a great company. I think most of these companies that are there in Singapore, given that the market is so lean, every company that you hear about is doing good work, because without doing good work, you cannot survive in the market. So any of these robotic companies that you come across in Singapore is probably a good company to work for.
Yeah, definitely. I think it's really about like finding that company that deals with the type of robotics that you're interested in. And I guess like any advice you would give to people in terms of finding the specific slice of robotics that they're interested in, like just a quick like one liner, how would you kind of like arrive on that?
You mean like deciding what type of robots that they want to work with?
Yeah. Like, how do I know if I want to work with vacuums? Is it because I like my Dyson vacuum? Actually, honestly.
Okay. Okay, so the vacuum part is more of an application side of things. So the first question is even more before that, what type of robot you want to work with. So for example, if you're interested in understanding how robots can move into a space where they have to coexist with humans, and a lot of this comes into the mobile robotics landscape, because they will have to move in public areas, very busy areas, through crowded streets, or even through crowded corridors in indoor environments. So if that's something that interests you, like how do you deal with human robot interaction? How do you make sure that you're able to avoid, say, dynamic obstacles, which is a big thing in terms of having robots and humans work together in one space. Or on the other hand, if you are more interested to, say, go into very intense physics, physics intense type of robotics, I would say manipulators is the way to go, because it's a lot of like math, and a lot of applications are simply in a controlled environment. So it gives a lot of focus on developing algorithms to make efficient ways to go from one point to another in a more controlled work cell, say in a manufacturing process. So I guess it depends on where the interest lies, that you can decide on which type of robot you want to work with.
For sure. Yeah. Thank you for like giving a brief on how to find your specific slice of robotics that you're interested in, which will definitely lead on to like what companies are there dealing with these specific robotics engineering fields, which is a good segue to also like the other dimension to consider that Celine was it, Celine brought up. Like, so other than like finding that specific slice of robotics you're interested in and the companies that deal with that, what about the team structure and the size of the company? How do you decide between small versus big companies? How do you find the small companies in the first place? Like, and what's the job market for robotics look like in terms of these kinds of organizational structures?
Sure. I think there's a lot more availability of smaller companies that are trying to make unique products in the space. I think big players like Siemens or Panasonic are definitely there, but they're more focusing on a few applications that they would like to capture the market for. So most of these other companies are trying to come up with very innovative solutions for other aspects of applications. So I think LinkedIn is a great platform that you can use to join these groups, robotic groups, and there's a lot of updates that you get from people from various backgrounds in Singapore, outside Singapore, all sort of sectors. So I think that's a great way to stay up to date, because there's a new company coming up every few weeks, every few months. So it can get a bit difficult to keep track of all the new companies that are coming up in the space.
No, yeah, totally. LinkedIn is a space for you to go to find those opportunities. Like you're gonna get like a different recruitment options from like the small and the big, because you're all trying to hire for demand there. So that's really a good suggestion. Get yourself on LinkedIn, even if you don't have like the perfect CV or resume yet. Like the idea is to just put yourself out there so you can be exposed to all these different opportunities and see all these companies, small and big. And I'm sure like the job descriptions for each will kind of like describe the team structure a little bit. So that might give you more insight based on your question, Celine. I think Celine had like sort of like another question in terms of pivoting between different fields within robotics. It seems like some of the skills are niche to each field. Just like you mentioned, different companies have like a specific slice of robotics, but what does it mean to kind of pivot from one to another? And have you done so within your role in Panasonic even?
Um, Sorry, can you rephrase your question? Like, what? Yeah.
Yeah, for sure. I think like Celine was asking how difficult is it to pivot between different fields, even within robotics? And have you kind of experienced that where you kind of thought like maybe I want to go to a different niche, and how difficult would that be?
Right. So I think jumping niche is easy and difficult at the same time. I guess it all depends on how far you want to jump. So if you're interested to say work in mobile robotics, but you want to say pivot into manipulators, there is a lot of field specific uh, knowledge that you have to get, like forward inverse kinematics, all these kind of things, computing matrices to sort of do all these different things which are only specific for actuated robots. But by and large, I think most of the concepts, like say planning a path from where I am right now to where I need to go, or how do I control the motors in a way that I'm able to reach where I need to reach. Some of these concepts are still fundamental, that are pretty similar across a lot of these sectors. So I guess it depends on what kind of jump you want to make. There is a lot of overlap in terms of the fundamental skills that you need. So I would say it is not very difficult to pivot, but again, it depends on how much time you have in hand to put in those extra hours after work to gain those skills and work on projects. Like I said, I think working on projects is the way to build skill and make sure that you're able to translate your knowledge to something tangible that companies can bet on when they give you a job.
Oh yeah, I think so. Basically, you're talking about like delving into different niche areas in your free time, even while you're in one niche. So you can kind of explore like different niche areas in robotics. And if you do find that through your side projects, you really like one, then perhaps like take that pivot. That I think I really like that idea of, even though you're still in like one niche, always take time outside of that to explore others, because you never know what you may find, and also the transferable skills, right? So I think that's excellent advice, and I hope that answered your question, Celine. We have a few questions and also kind of comments about the use case in the defense industry. So Arun was talking about how military application of robotics is also a very happening field. He's talking about future high risk work in the military could be entrusted to robotic soldiers, such as a wheelbarrow bomb disposal robot. And Chris was just talking about how Singaporean companies that work with the defense industry, very much like SE Engineering and NCS, might be involved in this. I can attest to that. I'm a military software engineer, and we're really going on into robotics in a very big way, because we deal with a lot of hardware. So I don't know for you, Adarsh, was like the defense industry something you considered when you were looking for a job?
Yeah, so I think from an application standpoint, I was open to explore everything. For me, it was more of my interest initially was to work on autonomous vehicles. That was mainly my interest. So as I was trying to streamline my job search, it scoped down to very few players in Singapore in terms of autonomous vehicles, and I think there's a lot of regulations put in place. So not a lot of companies are coming into that space yet. So then I had to take a step back and reevaluate my interests. And I think the closest fit for me in terms of interest level was mobile robots. So that was like a very seamless transition. So it didn't take much convincing myself that, oh, is it a field? Am I giving up on my dream or whatever? But I think it was a pretty seamless transition. I would say it's very similar in a lot of in a lot of aspects. Probably the only difference is that I work mainly on indoor robots, and I think a lot of it is outdoors in terms of autonomous vehicles, which is a very exciting space. So I can't wait for countries to start adopting these new technologies and ease in the regulation, so that there's a lot more players that come into these fields, including military applications. Yeah.
Yeah, for sure. Like it's not like basically you were open to all options at a point, right? Really trying to find a job that aligns to your interests, including the defense industry. So for all the participants here, you're looking for jobs. Don't worry to like kind of open your options across all industry, including defense. But you're also saying like find like a good niche area that you're kind of interested in. Like for you with autonomous vehicles, but also be open to pivoting to something similar. Like in your case, it's mobile robotics you mentioned like right now. So yeah, that's also a really good tip. Kind of remain open to all the different industry options, including defense, but also have like a rough like niche that you kind of enjoy, but also be open to like niche areas that kind of relate to it. That's great. Oh, Ella had a question. I was actually also kind of curious about it. So she's asking, is it true that by nature, all robotics need artificial intelligence or machine learning components for the sensors to decide what to do with the data? So maybe you could comment on this, and maybe you were talking about like how all these are actually integrated, both AI software as well as like robotics. So is this true?
Not really, not really. I think the scope for AI is very large to sort of revolutionize any sector. I think there's a scope for AI to play a role in every sector there is. But in terms of let me find this question. In terms of sensors and deciding what to do with the data, I think that's a very fundamental level at which we're using the data to do something. And due to safety concerns, when robotics applications or robotic solutions are deployed in real world environments, I think a lot of companies vote against using the data from sensors, especially to give complete autonomy to an AI to decide what to do with the data, simply because the explainability of the outcome is not there yet. So they still prefer having traditional ways of using, say, Kalman filters or combining data from different sensors, which are very tried and tested over many years. So I think it's more of a trust factor, and from what I see in the landscape, a lot of companies do use AI, but I think the scope of using AI in today's world so far has been only in terms of vision or perception. And not so much in terms of using like sensor data, say like odometry data or wheel encoder data, which is like a very fundamental piece of information that is used by the robot to move. Yeah.
Got it. So it's true, but it also kind of like depends. Yeah, I feel like it's kind of like an overarching statement to just say like all robotics are involved, have something to do with like AI and ML. Maybe the fear here is that, do I need to know AI and ML if I go into the field of robotics? But based on what you said, it really depends on the scope of the current like project that you're on. There's just so many different fields. So yeah, if Ella, that was your concern, not to worry about it. It's good to kind of like know a little bit and have a little bit of a grasp, but it's really dependent on the job itself. That's what Adharsh is saying. There is also a question by Andrea, supported by Samyukta, which I was also curious about. So what does your day-to-day as a robotic software engineer look like? And how does it differ from a normal software engineer? What do you think?
I think we can take turns. So first I'll talk about what my day looks like, and then maybe you can tell us about what your day looks like.
Yeah, perfect.
Yeah, so I think in terms of robotic software engineering, again, the scope is quite large. But commenting on what my day typically looks like, so there's two different types of work days, I would say. One where we're trying to develop new softwares or debug systems or at a software level before we actually deploy on the physical robot, and that means using a lot of simulation platforms. So whatever our physical robot is, we will have to create like a model for us to simulate and use physics engines like a Zibo or Ignition, and having our robot simulated on those platforms, then we can directly start using this virtual digital twin of the physical robot to deploy the software and see the behavior. And I think when it comes to that, it's very interesting and not very interesting in terms of, it's a very ideal situation that you have on a simulation platform. So it doesn't reflect what the robot has to go through when it's actually deployed. So I would say that's the first step in terms of approaching any new project or problem. And the next step would be, once we have like a minimal viable product or a software, then we take and deploy it on the physical robot. And that's when we stumble upon thousands of issues, and we spend a lot of time trying to debug, simply because like physical robots are very different from simulation robots. And there's when there's hardware involved, there's a lot of scope for things going wrong. And the development of the software would have been based on a certain assumption that I have this computation power that I'm dealing with, but in reality, some other process might be hogging up a lot of computation resource, and you might not be getting a lot of resource for your program. So it's a lot of iterating, I would say. It's a lot of debugging. So yeah, that's a typical day in the life of a software robotics engineer. Maybe you can go, Natasha. Maybe tell us what your day looks.
Yeah. Sure. Honestly, it's pretty much the same, except that our production environments are different, basically. And I would imagine for you, it's so much harder to get like a dev and like a staging and a test environment that's literally as similar as possible to a production environment. I guess like I'm a software engineer specializing in web applications with a little bit of AI microservices, but it's definitely like easier to maintain a similarity across the different environments. And I guess in your case, you literally, there's just way more things to consider when you push to production. You were saying way more things could go wrong because of this asymmetry of environments. I think for us, it's like so much easier if we, come into a problem where our infrastructure can't actually support the computational needs. We're in the cloud, so we can easily like scale. We can spin up another like VM. We can quickly iterate. So our like feedback loop is much more close. So the software production lifecycle, I would assume it's a little bit shorter, just because like we don't have like as long as of a iteration cycle towards the end of the phase, where in your case, when you push to production and then you're looking at how it performs on your machine, a lot of things could go wrong. And now I had to resolution and actually spin up more resources, but spinning up for you is literal hardware. But for us, it's like I click on our dashboard, very easy. So I would say it's mostly similar, but for your case, it feels more tangible. There's way more components involved. And I just like that tangible nature of things, because oftentimes, even after I push to production, there's always an instance of like, okay, so did it work? Like I have to write a lot more like end-to-end tests. I have to rely on those tests to make sure that to really see tangibly if things are working. But for you, you can literally see on the machine itself. It's like, oh shit, like now I have to debug this because like obviously it's not working. So it seems like in gist it's the same, just that for yours there's a more tangible nature to it. And if you're somebody, like you said, the traits of why you would want to go into robotics engineering, you're somebody who wants to see how humans and robots interact. You're somebody who loves like debugging as well and see things tangibly and solve all of these myriad of different issues that are contained across like a interdisciplinary space. Robotic software engineering is the field for you. Like I'm actually interested in like going into that field. Like I bought a Raspberry Pi a year ago. I was gonna build like one 3D printer to get started in the field. I mean, Sindhuja, I think you asked about like how would I purchase a robot? I guess this is your time to shine, because I do want to have that feel of tangible debugging for once in my life. So I would recommend a Raspberry Pi, but I have to say I have not actually touched it. But maybe Adharsh could recommend better options. Yeah, before like we kind of like jump into the options for how I can get started on robotics, which I also need, I think there was Chris was asking, I might have skipped this question by accident, but he's asking about your opinions in Singaporean companies such as ST Engineering and NCS, which are more directed to its security. I'm just gonna like put a little bit of caveat on this because I've worked with these companies before, just because I'm from the defense industry. I think a lot of the big difference between these and like bigger companies, commercial companies, is the organizational structure. Things do tend to be a little bit more rigid and structural in those companies, I would say. And you would basically be expecting a lot more stability in your job, actually. Like that's something I hear from people who are considering across the different types of companies, just because they work with the defense industry, which has a lot of budget and is connected to government. So I would say one of the things I hear from people is job stability, actually. But that's what I feel in terms of like a holistic HR perspective. But for Adharsh, like, what do you think? Did you consider these companies?
Yes. But I think in terms of application, the application is more of like a patrolling surveillance application that I've seen with these security companies, especially NCS and Certis, and a lot of these other companies. Kabam Robotics. I'm just throwing out names there that I'm able to recollect off the top of my head. Yes, so I think there's a lot more scope for AI in these kind of companies because you're dealing with a lot of visual data, and some of the applications would be to monitor if say in the front of a hotel or a building you have to have no cars parked, and then if you have a car parked in a specific area, then you can use your object detection algorithms in AI to sort of send a feedback to the system and alert them that you need to ask someone to clear off the vehicle. So I think if the interest is more on the AI application of things, because the movement of robot isn't much, and I was more interested for the robot to move in challenging environments, in live areas with more crowded and sort of complicated dynamic environments, and that was my focus. So I didn't focus a lot on getting into these security companies. But again, my comment on that would be that there's immense scope for AI, computer vision, especially in these companies, because you're dealing with visual data.
Got it, got it. So if you're dealing with more visual data and that's something that you're interested in, like SC engineering and NCS might be a good place to start. And you also recommended Certus as well. So these are companies that you could kind of look at if that's a field that you're interested in. So I hope that answers your question, Chris. Yeah, perfect. I think that covers a lot of the questions everybody had. I want to be sure of time. It's 4:59, so we're at a really good time. So I'm going to take this time to actually thank everyone for being here. Adharsh, thank you so much for taking your time today to be with us and tell us all about robotics and your journey as a robotic software engineer. I think we had really interesting questions because you had such an amazing presentation. So yeah, so you some here saying thank you so much for the amazing talk. I'm sure we all enjoyed it. I really hope you all walk away with like a good understanding of like what the field of robotics just briefly looks like and what are other steps you can take to start applying for these jobs. I think Adharsh talked a lot about different companies you could explore, about finding that specific niche in robotics that you would like to work on and what companies are attached to those niche. We'll also be putting this recording up so that you guys can come back and review it. Be sure to find Women Who Code like on LinkedIn. I've also put in Adharsh's LinkedIn there, so he'll also be spreading information on this. Yeah, so feel free to go on and like that. I will also plug in like Women Who Code like social, so you guys can come back to the site. And like I said, I really like the slide on like the step 1 all the way to 5 on how to apply. So I'll probably put it up on my personal LinkedIn and I send it to Adharsh to repost or something so you guys can look for him. Yeah. So yeah, any last words you have, like last pieces of advice you have for these like potential robotics innovators, Adharsh?
Yeah, so thanks a lot for having this event today. I think it was really insightful for me as well, hearing these questions from people who are interested in the field. And I would love to have more events like this where we're able to reach a larger audience, because robotics is still a very untapped field, and a lot of the spotlight is being taken by ML and AI today. So I think we need to put out more content and try, sort of make the field of robotics more visible to people. So yeah, looking forward to having more sessions like this. Maybe even like workshops, getting a bit more technical if that's what people are interested in. But yeah, I think the main thing is for us to keep the ball rolling and continue getting traction in the field of robotics, because it's an ever expanding and ever evolving field.
Yeah, definitely. I mean, obviously we'll be organizing more events because, like, yeah, we'll definitely be having you on board because you are an expert in this area. We would love to spread the word on robotics. You're totally right. I think robotics is such an amazing field, but a lot of it kind of like gets hidden under all the different buzzwords from AI and software. And a lot of people might not even be aware, not that they're not interested. So we do want to like keep doing these different workshop sessions, maybe a podcast or something to have people talk about their day on day because we're seeing so many questions on like what exactly is the difference between a robotics and a software engineer? How does your day to day differ? What are the different companies that offer that? So yeah, totally agree. We would love to do more events, especially with you, since you're always like at different like you know the Ross conference that you had in Kyoto. I'm just gonna revisit that and see if I can see a speaker talk. But would love to be there for those kinds of events as I explore robotics myself. So yeah, thank you everybody for being here for this session. If you want to look up more for events like these, we will definitely be organizing more. I've kind of plugged in like different socials. I have Adharsh's LinkedIn. He is an active like advocate in the field of robotics, and as you guys know, he's spoken in multiple events. So go on there if you want to see more events and opportunities. You definitely like go on to Women Who Code to look for more events, and specifically for Singapore-based events, do look for WW Code Singapore, the handle across our different socials on Twitter, on Instagram, and you'll be able to see updates on these different events. So yeah, thank you so much everybody for joining today on this amazing Saturday late afternoon. And yeah, shoot us a question. You can shoot Adharsh a question on LinkedIn. You know what? I'm gonna like put my own social down there if I don't know, you guys happen to have questions that you don't know who to direct to. So feel free to reach out if you're a little bit scared of reaching out on like the Women of Code like platform itself. So yeah, we'll kind of like hang around here for a bit, but again, thank you so much for being here. But here you go. Go enjoy your Saturday evenings, and we look forward to seeing you in future events.
Thank you. Thank you so much.
Mm-hmm. All right. I guess this is where we take our rest break and like, oh, that was a really good event. Thanks for putting in all of that information. Yeah, I think Sindhuja should be still on here. Yeah, thanks so much for connecting, Darsh. Like, yeah, I think she was talking about how she found you, and she's like, oh, I have to have this guy on board to talk more about robotics because it's like a passion to like spread more awareness on this.
Absolutely. I should appreciate you guys for putting out an event like this because I'm always interested to talk about the field, and I think this is a great platform. And yeah, looking forward to having more events.
Yeah. What kind of events do you suggest we have actually? Like, since you're more experienced.
Um, I think it depends a lot on what the audience would like to have. I mean, I'm more than happy to have these introductory talks because, like you said, a lot of people are simply not aware of the field of robotics, the visibility and you know. Mainly the visibility is something that's missing. So we can continue to have these sort of introductory talks. But that being said, I think there is a larger audience for us to focus on who might be students and are maybe already interested in the field but don't know how to go about building their own skill sets, applying for jobs. So I think we can explore events that are more focused on how to prepare for jobs, or even events that focus more on how to build skills. Maybe cover some fundamental concepts or maybe some hands-on workshops. So I think we have a very wide array of possibilities. But yeah, I think getting feedback from the community is a great way to know what they
Yeah.
might to see.
Exactly. Yeah, that is a
That
perfect
was
segue. I was just going to
excellent.
blast. Please get on the feedback link right now in the chat. Let us know what kind of events you would like to see from us, how you have benefited from this one session so we know how to tailor the experience for you. And as you put your feedback here, if you have any questions, we can reach out to you to answer them. So yeah, for the people who are still here, Ella, Chris, Sam, and Wai Hong, you guys are able to see the link on the chat, I assume? Yeah, maybe give it like a thumbs up if you can see it, and just click on it and give us your feedback so we know how to create more of these events. Yeah, Sindhuja, you were saying? Sorry, I cut you off there.
Yes, I was just saying that, Adharsh, that was an excellent event. lots of information to process. But thank you so much for putting it all together.
Thank you so much. I'm glad it added value to the people. Yeah.
Absolutely. I was surprised by the influx of so many questions. I'm just so happy that our audience was so live and active today. And looks like you have been able to cover the responses to all of the questions. So that's great.
Yeah, I was really happy about how everybody was responding and asking questions. And these are really good questions too. These were questions I had in mind. Wai Hong is clapping, so he's saying like, yeah, questions really good and content was good. Yeah, maybe the next event, like I would love to see your questions too, Wai Hong. Maybe if you have more questions, like definitely go on to the feedback link. We would love to hear your comments and questions if you have any that you weren't able to ask just now.
Some of these questions actually got me thinking as well, because on a day-to-day basis, some of these things we don't think about. We're so caught up at work and trying to get our day-to-day work done, that some of these are very insightful, inspiring questions that got me thinking. So yeah, thanks a lot to everyone who asked good questions and being a very receptive audience.
Awesome.
Oh, thank you so much, Ella. So nice of you to submit your feedback. Yeah, Sindhuja, did you have something to close off with?
That's right. So this has been a great event. So unless any of the audience members have more questions to ask, we can close off this event and get going with our Saturday evening.
Yes, I'm always open to have a conversation. You can hit me up on LinkedIn, message me anytime. I'm always ready to talk about the field, to help someone get into it, even have an insightful conversation. Yeah, anytime.
Awesome. That's great. So since we have a bit of radio silence from our audience, let's call it a day. Thank you so much, Adarsh. And thank you, Natasha. Natasha, you're such a natural. I'm so impressed.
Oh no, don't worry about it. Yeah, I love doing these events and getting like more word out there about like tech as well as like niche areas in tech. Like I'm just so happy to be meeting Adharsh today as well as you and just learn from you guys. Yeah. All right. Oh, Sam says thank you. Thank you, Sam. Yeah, have a good evening. Oh,
yeah, there's a
okay.
question.
Sam is still hanging around. Yeah. May I please know the programming language you use the most for robotics? I think you mentioned C++ and Python, but yeah, go off like on this part.
Yeah, so I think C++ and Python, sometimes Java, but mostly C++ and Python. But even within that, I would say 90% of companies go for C++, simply because, as you know, it's a very hardware intensive field. And when it comes to edge deployment, we're dealing with limited resources. So that calls for efficient programs. And I think that's possible only with a language like C++. So to answer your question, I think C++ should be the one for you to pick up. Although I know it's not very user friendly, especially for someone who is looking to get into programming. I am very well aware that C++ is not a very helpful language for you to have to have it as the first language you learn. But unfortunately, that is a language that is the most widely used by companies. And yeah, a lot of these concepts you can learn through C++. So yeah, I think C++ should be the one for you to focus on.
Yeah, perfect. Thank you for answering like an ad hoc question like that. But yeah, C++. Like I feel like that's the foundational language to teach anyways, even though like I prefer my TypeScript and JavaScript. But no, like I will get back to C++. And there's always Python if you guys are scared. Okay, Sam says thank you. Thank you so much, Sam. Yeah, have a good Saturday evening. Yeah, but no, I promise I'll get on C++ again. Like I've been so rusty, but maybe Rust,
Maybe
low-level
Rust.
programming language is a little bit more accessible. Yeah.
But I think the main thing is that a lot of these open source softwares that people can use are mainly in C++. But there is a lot of traction in these other new age languages like Rust as well, which I see is being used by a lot of companies coming up. So I think a lot of existing resources are in C++, but there is a definite shift towards other languages as well. Yeah.
Yeah, for sure. And there's a new programming language every single day. So like, who knows how it might shift? Yeah. So Sam, I hope that we answered your questions. And if you have time to go on like the feedback link, and if you have more questions, you can put it up there. Chris as well, thanks for staying us all the way through the event. Loved your questions. Yeah, again, go out with the feedback link if you have more. We're just gonna hang around for a bit. And Sindhuja, do you think like we should? Okay, I'll basically kind of like close up the event right now. Just head on to the link if you have more questions. Thank you again, Adharsh, and thank you, Sindhuja, for putting this together. You guys have a great Saturday evening. Like, we can connect on socials after. I feel like I have more conversations, but like, yeah, we can bring it to the socials. Yeah.
Absolutely.
Have a good Saturday evening, guys.
Bye-bye. Thank you, Natasha, Sindhuja, Chris,
Yeah.
and thank you so much.
Yeah. Bye, everybody.
Bye bye. Bye, guys.
Bye.